Hello everyone, and welcome to today's webcast, Hands-on USN Journal Analysis. My name is Trevor, and I will be moderating this webcast. Today's featured speaker is David Cohen, partner at GC Partners. Before I turn things over to him, the Q&A portion will take place at the end of this webcast. Please feel free to submit your questions at any time by using the questions window. Right now, I'd like to turn things over to David.
Good morning, everyone, or good afternoon, depending on where you are. Today, I think you're going to enjoy what we're going to go through for a couple of reasons. So this was a lab that I did when I was in Utah. It was an hour-and-a-half to 2-hour lab, and we sat down at the Paraben conference, and we went through different examples of USN journals and the fun things you can recover from them. And the important thing, I think, for you, because we're going to go through a couple of different examples of things you can recover, is that these topics are going to go away. You're going to kind of forget what you're asking about. I want to make sure that you know that you can ask questions at any time. So if you have a general question, you don't want to ask it right away, save it for the end, not a problem. Trevor will facilitate that. But as I'm going through something, if you have a question, I want to make sure that you can get it in when you think it's relevant. So make sure to ask it at any time. Trevor will get that question to me, and we'll get your answer taken care of. So, if you don't know who I am, my name is David Cohen, or Cowan, depending upon what part of the country you live. It doesn't matter to me. I am a SANS instructor. In fact, I am teaching 408 with Chad Tilbury in January in New Orleans. So if you're looking to take 408 and for some strange reason you have some last-minute budget to take care of, come on down to New Orleans. We'll have a great time. I'm an author. I've written a couple of books on forensics, Hacking Exposed Computer Forensics, 3rd edition of the Anti-Hacker Toolkit, as well as the new book, The InfoSec Pro Guide to Computer Forensics, and we're currently working on the 3rd edition of Hacking Exposed Computer Forensics. I write a blog called the Hacking Exposed Computer Forensics blog. I'm an expert witness. I go around the country testifying about computer forensics stuff. I'm a digital forensics researcher, and I have a beard. Probably most important on this list is that I have a beard. That's probably what I'm most well known for. Everything that I'm going to go through and demonstrate is something that you're going to be able to download and do yourself. I want to make sure that I remove some of the mystery behind using our tool, tools like it, and USN analysis in general. The biggest struggle that I find when it comes to these analysis techniques and this technology is that people are struggling to understand, 1, why it's relevant, 2, why didn't no one really tell me about this before, and 3, what can I actually do with it? So with that in mind, I'm going to be showing you how I'm going to go through and recover certain facts and artifacts from these journals to be able to tell a story and explain what happened on the system. But I want to make sure that you know that when this is done, I'll be uploading all of these things up to the blog so you can download all of the labs, and you can do everything that I'm going to be showing you. I'm doing it all with a free version of the software so that you can try this out for yourself. Now, you don't have to use our software to do this, obviously. It's just a USN journal that we're providing you. You could use any other parser that's out there. I just think that ours is easiest to use, and it's free. So you really can't complain about that. If you can, I really like to hear that, because that would be a pretty amazing complaint, to be honest. One of the things I want to make sure that you understand, coming into this and taking away from this, is that we are still kind of in the first phase of journal forensic analysis. In other words, we've written good parsers, we have pretty good analytic tools now, and we understand certain basic facts and application states that we can recover to be able to determine things that users were doing. But we are not in a position now where we can say, hey, I know everything about what gets written to the journal as far as understanding what you can recover. So there is a lot of room here for discovery and new research and new things. So if you're looking for that thing that you can research, thing that you can kind of put your stake out into the world to understand, get people to understand your value and be able to fund your research, this is a pretty great place to start if you wanted to be able to say, hey, look what I figured out, because there's just so much here. So we're going to talk about a lot of things. Most importantly, what is a USN journal? I know that the description of this podcast said we talk about different file systems, and I will get into kind of some of the other file systems and the differences. But this talk really is focused on USN journal analysis and showing you how to do it. We're going to talk about what kind of data does it log, how long does it keep it. I'm going to show you our tool, and then I'm going to walk you through how to do these things yourself. So, what is the USN journal? Now, a lot of people get a lot of confusion when we start talking about the different journals that exist, because there's a lot of journals in the world. A lot of SQL databases have journals. Exchange servers have journals. File systems have journals. Adults and children have their journals that they write in. But in this case, the USN journal is very specific. It stands for the Update Sequence Number Journal. Now, that's what Microsoft decided to call it because its identifier for understanding where you are in the log and what entry you're discussing is called the Update Sequence Number. That's the entry number. And it's stored as an entry in the MFT for the file itself. But that part really isn't as important. I like to call this the change journal, which is different from the other log file you probably heard me talk about, which is the $ log file in NTFS, and I call that the metadata journal. If you're talking about extension 3 and 4, or talking about HFS Plus or one of the other journals, they have a metadata journal, but they don't have a change journal. The change journal is kind of unique to Windows, as far as I know. So what does a change journal record? Well, it logs all of the changes that have occurred on a partition. Everything. Now, it doesn't log them forever. Over time, the change journal will grow large enough that it will free pages back to the disk. And we're going to talk more about that and why that's so important to understand. It's available not only in NTFS, but it is also available in REFS because it's not a file system implementation. In other words, the $ log file metadata log, the metadata journal, is NTFS specific. REFS has actually redone its whole structure for metadata logging into an internal system database, so it doesn't have the $ log file anymore. But the USN journal is more of an operating system level artifact. So because of that, you should be expecting to find the USN journal to be consistently available even as new file systems come out, as long as Windows is running on top. I say that, as far as I know, FAT does not have the USN journal, but who knows? I could be wrong. As far as I know, that's just not a possibility. USN journals became default as of Windows Vista. It's been there ever since. So Windows Vista, Server 2008, Server 2012, Windows 7, Windows 8, it's there. You could optionally turn it on in Server 2003, but most people did not. And you may be wondering, well, why is there this journal if it doesn't relate to the file system? Well, it's part of what makes Windows search indexing work. So if you sit down and you think, like I tried to, why is this there? Why did someone create this? Because, you know, popular conspiracy theory is that all these things are secret NSA backdoors. That's actually not true. What you have here is a really neat developer trick. They said, boy, wouldn't it be great if we could just keep track of the files that have changed since the last time I looked at the disk? Wouldn't that be nice just to know what I need to look at to know what's changed so I don't have to rescan the whole disk again? That's it. It's really easy. So they did that. They said, okay, let's create a journal that records what changed. And then things like the Windows System Indexer can look at that and say, oh, only these files have changed to the disk. These are the only files that I need to go back and look at when I go back to update my index. And have virus scanners to do the same thing, so it can back up software. And it's actually an API that's fully exposed so that people can subscribe to the USN and monitor these changes over time. So what does it log? File creations, deletions, overwrite, truncations, extensions, renames, alternate data stream changes, insertions, basic info changes. Those are changes to the standard information attribute. Basically, if something is changing, creating, or deleting the contents of a file, it gets written to the USN journal as a nice single-line entry. And the nice thing about USN journals from a forensic analysis perspective is that each individual entry contains a couple of specific things. Number one, it actually has the file name separate and apart from the MFT reference number. It has the parent reference number. It has the reason code that identifies what change is happening. And then, of course, what we all like to hear is that it has a timestamp to millisecond precision for every operation it logs. So just on its own, if you do no other type of intelligent analysis and you're just looking to increase your timelining capabilities and really understand what happened on a system, what changed, and what events occurred on a system over time, you can do that by just looking at the base USN journal. The problem with looking at just the base USN journal is that it's very large and it has a lot of data. So unless you have some really good form of logic to help you kind of pick it apart and understand what's going on, it's just going to turn into a lot of noise with some interesting parts in between that you need to be able to go through and filter out. So how long does the USN journal keep data? Well, that's going to depend upon the number of journal entries that occur. So for instance, let's say that you had a system drive, your C drive, Windows is installed on it, and there's USN journal on it. If it's system forward, there should be a USN journal on it. I found that typically you get about 2 weeks worth of time. Could be less, depending upon how many transactions are occurring on that disk. If you're talking about a secondary disk, a data disk that doesn't get as much activity, maybe seeing up to 2 months. If you give me an external hard drive with the USN journal, we'll talk about that some more about when that happens. I may see a year back in time. So it's not a time-delimited feature. It's a data-delimited feature. How much data is being written to the log, and after a certain number of entries, it will finally start freeing pages near the end. Now, the live disk isn't the only place we can get USN journals from. We can also get USN journals from volume shadow copies. The volume shadow copies actually have, for each one of the backups made, a full USN journal for that time period. That's very useful because suddenly we're extending our view in time back for as many volume shadow copies as we have, and it's a full capture of the changes that occurred prior to that time. Very, very useful. Depending upon what volume shadow copy tool you're using, though, it may not be exposed to you. Because if you're using the Windows API to access volume shadow copies, it's actually filtering your ability to access certain system files that are being captured because they don't want those exposed to the previous version functionality. They don't want people to accidentally or intentionally screw their system by exporting out system files into a shadow copy individual file restore. So if you're using something like VSC Toolkit, if you're using something like ShadowKit, Shadow Explorer, all these things will not show you that these files exist. You have to use something that's actually doing a non-native access to the shadow copy. So it's doing a full parse of the partition and the shadow copy database to rebuild the structure of what files are actually contained within it. libvshadow does a great job of this. It's a free and open source library. Xways does a great job of this. And FDK is actually, from what I've been able to tell from looking at the licenses they're including, using libvshadow within their code. So FDK is also showing it to you. The other nice thing about using libvshadow is that because it's parsing the raw disk, even if a shadow copy has been marked deleted by the operating system, there still may be an entry within it inside of the shadow copy database. So you still may have recoverable data that from a deleted shadow copy. The last thing to really understand that lets us go back in time about USN journals, and it's something that we didn't realize until actually the SANS DFIR Summit when we got to sit down with Troy Larson and give him a demo, is that USN journals are sparse files. And that's great, but what does that mean? It means that unlike the other log files and journals that we're used to, where over time they overwrite themselves from the beginning, USN journals don't do that. So for those of you who have experience with USN journals, one of the big mysteries has always been, why is it when I export out my USN journal using my forensic utility that I have gigabytes and gigabytes of zeros leading up to the actual data that I'm looking for? That doesn't make any sense. Why would it do that? If it's overwriting itself, why would it just keep adding more space with zeros? And the reason is that our forensic tools are wrong, basically. Our forensics tools are treating the sparse data as if it's real data. What I mean by that is that over time, the USN journal will simply say, okay, I need another page to write data to as it goes along, but the other pages it frees up to the disk. So it's not actually taking, for instance, I had one client with a 500 gigabyte USN journal. 500 gigs of space was not actually being used on that disk. Only about 3 gigs of space of the actual USN journal was being used. But because our forensics tools are simply trusting the data being provided to them, it's going through and seeing all the page allocations that have ever occurred that are being buffered in to make this file look like it's 500 gigs. Why would they do that? Why would the developers implement a feature that would create a false sense of a larger file? The answer is, again, neat developer tricks. The people who wrote this said, wouldn't it be nice if the USN journal number, the update sequence number, was always equal to the offset of where this entry was in the USN journal, so I would never have to spend time looping through gigabytes of data to find where this transaction occurred. I could always jump directly into the absolute offset where this transaction is recorded. And so to do that, they emulated the log file getting bigger and bigger, so the offset value was always true. Now, while that's interesting to know, and it helps explain why you get so much nothing data, what that opened the door for us to understand is that those freed pages aren't deleted or overwritten. They're simply freed to the disk and are sitting around in allocated space, which means that you can carve USNs. And in fact, on every system that has a USN journal, you should expect to be able to find carved USN entries, unless, of course, the disk is so new that there's no freed pages yet, or two, someone wiped the free space. But otherwise, I would expect to always find carvable USN data just ready to go and pick up. And depending upon the disk and the activity and the length of time it's in operation, we've gone back 3 years, and that was pretty incredible. So let me show you the tool that we're going to be working with today. Make it a little easier to see. So we call this tool Triforce. Why do we call it Triforce? Because it takes in 3 artifacts: MFTs, log files, and USN journals. What do we do with Triforce? Well, let's see if I can make this even more readable. With Triforce, we can go through and parse out your MFT and your file system journals in order to reverse back in time all the changes that happened on the disk, all the things we just talked about, but do it in such a way that we can provide you much better analytic capabilities in both the free and the commercial version. So I'm going to walk you through kind of the workflow of Triforce here, so that way when you go to do this on your own, you won't get lost. And then we're going to go straight into the labs themselves and talk about what you can recover. So when you see case name here, you can put anything you want. So I can put SANS, Webcast. The case name, all it's going to do is create a database with that name. Not that big of a deal. The case path, that's just going to determine where you store the database. So in my case, I can go through here and I can pick the root of my E drive, where I have my test files right now. And then the MFT, well, I put in the MFT there, the log file, I put the $ log file there. And the USN is actually a little tricky. So I'm going to go ahead and start up one more utility that I'm going to share, because I want to show you where it is you can actually go and get this data from. Because I think a lot of people are familiar with the MFT is, but I think less people are familiar with where the USN journal is. So I'm going to sit here, I'm going to add see, hopefully you can see my screen right now. No, it doesn't seem like you can. Oh, there. Why is this not up here? Okay. Try this again. No. Okay. Well, let's just go ahead and there we go. Okay. So I'm going to pick my physical disk, I'm going to pick the local drive, and I'm going to show you where you can get this data. So here I am. I'm at the root of my partition. Here is the MFT. I think most of us are familiar with the MFT by now. Master file tables, where all your file data is stored for your NTFS drive. Right above it is the $ log file. So this is the metadata transaction log I was talking about before, that we've talked about before actually in these webcasts. But if you want to get to the USN journal, this is where the tricky part comes in. It's under $extend, USN journal, and then from there, it's an alternate data stream called $J. So $J, the ADS stream under USN journal, is actually the place where the USN data is stored. And if you go through looking here, you're like, boy, that sure is a lot of zeros, and it's all the way to the end, poof, you get your data. So that's where you get these three files from. I think that's pretty important to know before we go any further. So back to Triforce. So if I come in here into Triforce and I said, okay, let's do one of these. I can drag and drop an MFT here. I can drag and drop a log file here, and I can drag and drop a journal file here. And then I can go into what's called event selection. If I do that, I can see that the free version has 3 events defined: creations, deletions, and rename. So this is what's going to pull out and highlight for you under the events. If you're using the commercial version, it's got a big long list underneath it of all the other stuff it can figure out and parse for you. But what I'm going to show you today is how to use the free version to emulate some of the signatures that we do in the commercial version, and also just extend your analysis in general. Now, under the options, here you can pick a time zone. If you pick a time zone, it will make your time local. So I'm going to leave this one blank, so it defaults to UTC. You can pick a cluster size and an MFT entry size. Why did we make this variable here under cluster size? Because even though cluster sizes are fairly static at either 4K or 32K today, as drives keep growing in size, for instance, an 8 terabyte drive just got released in the market, we expect to see cluster sizes grow. And the cluster math is important for us. We want to make sure you can always do that right and future-proof our product. Beyond that, this is some things you can do for memory control here, as far as how much memory it's going to use. You can choose your logs to timeline date formats, and you can write a debug file. If you're having problems, you want to send us a bug report. So that's it. At this point, I filled in my case name, my case path where I want my database stored, and what I want to parse, and I can just click parse. And when I do that, this is a very small thumb drive, so it's going to happen pretty fast. You can see that what it's doing here is it's going through the MFT, it's going to the log file, and then it's going to the USN. And then it's updating its index of records. Now, the most important thing here is what it says, reclaim. What does that mean? It means that we're actually going backwards through the USN journal against the master file table, and the same thing for the $ log file. And we're creating the state and time for what that MFT entry looked like through each transaction in reverse. That way, we always know the exact state of the MFT during that transaction, and we can buffer up all of those changes and store them in the database. What we don't want to do is point to something that's incorrect. We want to always make sure that we're pointing to the right resource, and this is actually even more important when you start dealing with the $log file, where a lot of the times you don't know the file that's being pointed to unless you do things in reverse order. So that's just my tip of the day for you. Replaying in reverse order, very important to get journal forensics right. If you wanted to save this log, you could do so by clicking on Save Log. I'll say, hey, where do you want to save it? In this case, don't need to save it. When you're done parsing, you get this handy-dandy little report screen. Now, if you click on USN record listing, that's going to give you, oh, sorry, I always have to click Command first. That's something we're actually working on fixing. If you click on USN record listing, it's going to give you all the records inside the USN. If you click on USN events and then transaction events, it'll let you break this down by the actual transaction event, the signature. So if you wanted to export data from here, you click on Export, pick your options, text, or just CSV, or Excel. If you wanted to filter it at this point, you click on the filter button. And you can do other fun stuff, like you can see the number of things recovered. And of course, what everyone likes to see, you can do full log the timeline output from here straight into your timeline tool of choice. So that's how to use the tool. It's pretty easy. I'm going to go more into the filtering capabilities in a second. But I think it's time to switch over and get to what you actually came here for, which is labs. We're going to go over a couple different scenarios. I still have 30 minutes left. I didn't think it would take this long, but I want to make sure you really understood how to use your tool, because I know it's not the most user-friendly and easiest tool to use. So let's get straight into it. And let's go to the most popular thing that we show that people seem to like, and that is how to figure out what was wiped. Which, conveniently, is exactly what I just parsed, is to wiping. It's really fast. So what do wipers do? At the base case, what do all wipers do? Wipers always will follow the same basic thing. This question: what was the name of the other utility the speaker found the USN in? FTK Imager was a tool that I was using to extract the USN journal. And the path, again, is $extend, and then there is a file called USN journal under there, and a $J alternate data stream off of that. So here we are. Let's get into what wipers do. Wipers always perform the same basic operations, but in different orders with different characteristics. So wipers will, A, rename the file, so you don't know what the name of the file was previously. B, it overwrites the file, so it puts new data over it, so that way you can't recover the prior contents. C, typically it will change the timestamps of the file. That way you won't know when the file was created, modified, accessed, or deleted. And then lastly, it will delete the file. Now, the order upon which it does that and the choices it makes for things like file names and timestamps and the patterns for wiping, those are all the things you can use to try to figure out what kind of wiper it ran. But at its most basic thing, and you can always look for first, is, let's look at some renames. So in this case, I'm looking at some renames, and I'm seeing something very interesting here. Here's a file. It used to be called images test files. And you can see right here that this file used to have a really nice and normal name. But now its name is completely random. That doesn't make any sense at all. And I see this again here, and again here, and again here. As I go down, it's always old file, new file. How do I know that for sure? If I just move one more over, you can see that the USN record reason says old name and new name. Old name, new name. Because that's the nice thing about USNs, is that the reason code will actually have one entry for the old name and one entry for the new name. How do you know you're talking about the same file? Right here. The USN file record number, the reference number, is going to show you, as long as this value is 40-1, this is always talking about the same file. This is 40 is the MFT record number, 1 is the sequence number. Now, sequence numbers are important because MFT entries get reused. And the sequence number at 1 means this is the first time that file record was used. What throws a lot of people off is when sequence numbers get incremented because they don't get decremented out. So upon deletion, the sequence number goes up to number 2. Upon deletion again, the sequence number will go up to number 3. And a lot of people thought that the sequence number would go up when the file gets reused. And that actually threw off some parsers. So as long as you're looking at the same exact file record number and reference number, sequence number combined together, what's called the reference number, you always know you're looking at the exact entry that you're referring to. So in this case, we can see that 47-1 is the value for these two records. So we know this is the old name and the new name of this specific file. 40-1 is the same way, this specific file. So here's files that have been renamed to weird names. Very suspicious, probably something that we want to know more about. Here's one, not stuff, has an easy to remember value, 101-1. And now I can show you one of the easy ways to filter. So I can right click on this, I can say filter by value. It's filled in the values in the column for me. I'm going to say like, add, and filter. And when I do this, it's going to show me just the records for 101-1. So I can see that it was renamed once, and that was it. Well, that's interesting. But what else happened to this file? So now I can go jump up to USN record listing. I'm going to click on filter again. And I'm going to recreate it. Let me do this the easier way. I'm going to right-click on USN reference number again. I'm going to say like, and I'm going to change the value to 101. I'm going to say add and filter. When I do that, what I'll get is exactly what happened to this file from its creation all the way down to its eventual deletion. So this is the life of this file. So here I can see it's created, data initially is populated into it, timestamps get updated to it, and then right about here is when funny business starts happening. So data overwrite. What do you think data overwrite means? Well, in this case, data overwrite means that this is the actual wiping occurring. This wiper actually will go through, and before it renames, before it does anything else, it'll do its overwrite. So this is the actual wiping process here. And for every overwrite pass picked, you're going to see a separate data overwrite reason being written into the USN terminal. And if you actually told it to wipe slack space, you're going to see data overwrite and then data extend, because it's making sure that the file is now big enough to encompass the slack space of the file. So in this case, we have 1, 2, 3 data overwrites. So this is most likely a 3-pass wipe. Here we see basic info changes. These are the timestamps being reset. Here we see the file being renamed and then deleted. So just like that, we now know the life of this file. When you start looking at different wipers, what you'll see is that every wiper has a different pattern. This is actually BC wipe. So BC wipe has one particular pattern that it follows. When you look at CCleaner, you'll see that it always rewipes the files to have the name to be all Z's. When you look at sdelete, you'll notice that it doesn't change timestamps. When you look at eraser, you'll see that it picks interesting file names depending upon the options that are set. So all of these things together really allow you to start profiling wipers and be able to put this together yourself. So this is a fairly easy way where you can now say not only did a wiper run, but you can now say exactly what was wiped and what options were picked. So that's pretty powerful, pretty useful, especially when you can say how far back to go, depending upon what your suspect is up to. If they're trying to get rid of evidence against them, are they trying to get rid of toolkits they're leaving behind, are they just trying to get rid of the internet history? All these things you can actually recover. Now, you can't recover the contents of the files, they are really wiped, but now at least you know what it was they were wiping, so you can get a bit more intelligence and understanding about that process. So we're done with this example, and let's move on to the next one. A lot of the other things that we hear is Dropbox. Can you tell us more about Dropbox? Why do people care about Dropbox so much? Well, obviously Dropbox is a great way to go and transmit data out of a system. But at the same time, one of the other things about Dropbox is that Dropbox decided to change its database scheme about a year or so ago and start encrypting it. So they made use of the Windows built-in encryption to start encrypting the Dropbox database, which was kind of our resource to be able to figure out what was previously stored in Dropbox, what was recently transferred, recovering deleted records, good SQLite database. And so suddenly we needed to have the user's password, because that is the key for Windows default encryption in Windows 7, to be able to get access to these files. And depending upon the system, that could be a real problem. One of the ways that we're doing it now is we're using volatility or password forensics, depending upon which is easier for us to grab at the time, and we're passing in hyperfiles to recover plain text passwords, and so we can use that. But even then, the SQLite database only goes back so far. So if I want to know more about what's going on inside of someone's Dropbox, well, I can just do USN analysis to be able to see what was going in and out of that folder. And there's actually some other cool stuff we can figure out. So I'm going to go ahead. I've preloaded the Dropbox database that we parsed. And now that I've done that, my screen will refresh. Now, this particular database was made with the commercial version of our tool. And that's actually one of the unintended features of our tool, is that if someone creates a database in the commercial version, you can pass it to someone with the free version and it will load just fine. Now, you can see here that we have a couple of different signatures that have matched for Dropbox here. And I want to talk about how each of these work. So the first one you see is Dropbox file synced from cloud. How can we determine that a file was actually downloaded from the cloud to the system and not the other way around? So the answer is, what you'll see here is that you have files being renamed from a temp file in the cache to a valid file name in the Dropbox directory. You can see here we're talking about the same file again. Same file record number, same sequence number. So when a file is being downloaded, Dropbox give it a temp extension. And until the downloaded session is complete and the download was successful, it will stay a temp file. So if you have something that was attempted to be downloaded but never was successful, then the temp file will stay a temp file and never be renamed. But once the download is successful, the temp file gets renamed to the actual file name and then stored in the directory it belongs in. So using the signature, we can pretty easily pull out exactly what was being downloaded from Dropbox. Now that's something different from something being copied into the Dropbox folder to be uploaded. In that case, we'll get files being created inside the Dropbox folder, but we won't get any temp files. Files being moved is also similar, but a little different because it's the move is actually considered a rename, but we're getting a rename from outside of the directory. So that's in the commercial version. It makes it pretty easy to see, but what if you had the free version and you want to do this yourself? So let's pop on over to the USN record listing. Yeah, take a second to load. And what we're going to do is we're going to create a filter that emulates our logic. So I'm going to show you how to do one of our signatures for free, because the point of our work isn't to hide all this from you. We want you to get the commercial tool because we think it helps you. We want you to be able to do this work and research yourself so that that way you can do better and find better evidence. So I'm going to populate this block that says value with %, Dropbox, %. So let's remove this line, the filter. And now, why am I putting %? I'm putting % because that's the wildcard for SQLite, and that's what we're using in the back end. We have a question. Would you see the same with Box.com? The answer is if you have the local Box.com agent installed. And this is true for any other of these cloud syncing sharing services. As long as you actually have the local agent installed, so it's downloading things from the internet this way, then the answer is yes, absolutely, you're going to see the same behavior. If they're downloading it from a website, what you're going to see is things called like .park or otherwise that the browser is using to determine what to download and when it's done and fully stored. So hope that answers your question. Same thing for Google Drive, Sugar Sync, OneDrive, all the rest. So here I've populated % Dropbox %. I'm going to say add. The column that I've picked is the extra full file name because that has the full path, and I'm going to click filter. So now it's going to go from 105,000 rows of USN data that we got from this system, and it's going to drop it down to 1,900. Now, you can see here that I have a whole lot of records, and it's still not giving me exactly what I want. Why is that? Because I'm getting a whole lot from the Dropbox system roaming. So in other words, this is the Dropbox program database and all the files relating to it, but not exactly the user data showing me what's being uploaded and downloaded. So let's refine our filter. So I'm going to come in here, and now I'm going to say, just show me Dropbox that is at the root for my user. remove this filter, and filter. And now that I've done that, I'm down to 159 rows of just what's happening inside of my user's Dropbox folder. And so now I'm able to find all of the activity going in and out of Dropbox. I'm going to see what's being deleted in Dropbox, what's created in Dropbox, what's being downloaded from the cloud of Dropbox. Here we can see these are the temp files showing files that are being downloaded. If I scroll to the right here, we can see files being created in Dropbox, being copied over, files being copied over. So all of these are great indicators showing exactly what's going on, whether or not we can actually decrypt the Dropbox database. So when you especially start taking in the shadow copy version of the USN journal and you start carving USNs, you can really start putting together a really powerful package of exactly what was going up and down to a number of the cloud syncing applications. So I found this to be very helpful, especially when the Dropbox database is either encrypted with a password, or two, if I want to have a better understanding, because the Dropbox database will only keep some delete records. So those are the first two examples I wanted to show you. Let's move on to the third. So let's take a look at Outlook attachments. This is actually one of my favorites because I use this a lot. So I'm going to connect to the database that we've already created. And I'm going to jump straight to the event center. So in this case, what we can see is that we've recovered a whole lot of different signatures. And one of the ones that we're seeing here is Outlook open attachment. So I'm going to go into the USN record for this. I'm going to look at Outlook opened attachments. And what I'm going to see is the names of files that were being opened as attachments from Outlook. Now, why is that? So let's talk about that for a second. Attachments to emails are stored in MIME format. I think that's something we are all well aware of. And so in order to access the contents of those attachments, either you have to preview or to open it or save it, it actually has to extract out that data from the attachment and store it on the disk in order for the data to be seen and accessible. So if someone's clicking and previewing, or someone double clicks to open an attachment, it's going to be writing out to the Outlook temp directory to do so. Now, in versions of Outlook 2003 and previous, that was great for us because Outlook didn't clean up after itself. So for every attachment that was opened, we could go back and find all of the attachment names. We could see how many times it was opened, because it would never overwrite a file, and instead it would prepend a number to the end that said 2, 3, 4, 5, relating to how many times that attachment was accessed and extracted. And we could use it, look at the timestamps of the file name attribute to determine when exactly this actually happened. And that was great. Analysis was easy. We didn't need anything else really to determine that. But starting out with 2007, and it's been consistent ever since, Outlook changed. I think if again, I like to pretend what really happened, is I think part of the development team got together and they went through the most common issued tickets and complaints about Outlook. And I'm pretty sure that what happened is that they said, boy, if people sure are mad that we keep filling up the temp directories with attachments, maybe we should clean that up. So now, as long as Outlook is still running, when an attachment is closed, it's deleted. If Outlook closes before the attachment does, then the attachment stays there forever like it used to. Question, is there a file carving signature for USNs? Yes, absolutely there is. And we'll talk more about that. And I'll show you, I talked about tools that currently support it and signatures that we're building to help other tools do it better. So now you're probably saying to yourself, okay, that's great. It's deleted, not that big of a deal. We're forensic people. We cover deleted files all the time. Well, that's true, but a lot of people forget that one of the big changes of Windows 7 is that defrag now runs by default every Wednesday at 2 a.m. And if your system isn't on at 2 a.m., then it'll run defrag as soon as it can and your system's idle long enough for it to run. So every week your MFT is being cleaned out, and every week you're losing deleted file records, which is why Windows 7 systems don't seem to have as many deleted files as older operating systems do. And that's a real pain. So that means that the journals now become the only place we can really go to find all of these different types of actions and accesses. Now, how can we then, using raw analysis and not having our handy-dandy super-duper commercial tool, figure this out? Well, you can see that we have a pretty easy signature here. We have a directory called content.outlook, and this is Outlook 2007 going forward, where all of these files are being written to into a prefix directory. So I'm going to come here to my full record listing, and then we're going to do a filter that's going to do this manually. So you can see how to do this yourself. Now, all of this, again, is SQLite backended, which means that you're free to not use our interface for all the queries you want to do. You can use any SQLite browsing tool you want. Just connect to it. We don't encrypt or protect the database in any way on any of the versions. We like Navicat for our SQLite interaction, but anything works. So I'm going to come in here. I'm going to pick extra full file name for my column. My condition is going to be like. You can notice there's also a full regex implementation. And then I'm going to say content.outlook. I'm going to say add. I'm going to remove the old Dropbox one, and I'm going to hit filter. One of the other things you can see is there's a button here that says export and import, and that means you can export and import filters. You can have saved filters. So in the background now, SQLite is going through, taking our 284,000 records in this particular USN journal, and it's going to limit it down to just the ones that contain content.outlook. Here we are. So now we can see these are all of the files and folders. I'm going to show you first just the directory that are inside of this content.outlook directory. Now, if you have multiple users of a system, each user has their own content.outlook directory, so this filter will show you all users' attachments open. But let's look at what we see here. Well, looks like we have a file being accessed called test file, we have a zip file, all sorts of different files. We have a lot of data because we're seeing all the changes that are being made to them. So we're seeing them being written out, them being deleted, and so we'll see that a lot actually, so let me show that to you. So you can see files deleted, because every time an attachment is closed, it's going to be deleted. But what if we want to make this a little more useful? What if we wanted to add on another filter? That's not a problem. So let's take our record reason. I'm going to say like, and I'm going to say %, create. So we now have two filters. If I hit filter again, it's going to take our 146 records now and take it down to 35. So now we can actually see the names of the files that are being created inside of this directory. A lot more simple of a list. And at this point, typically, I'd probably take this out, I'd click export, and I'd say Excel, and I'd export it out so I can get it into a form that someone else can start looking at. Why do you care about attachment accesses? Well, usually because people are lying to you about them not opening attachments. That's one. I have that a lot where people that I'm interested in investigating are saying, yes, I received it via email, but I never looked at it. But let's say you're doing more traditional IR and someone's being spearphished. Wouldn't it be nice to be able to know what executables were actually being written out into this directory? Because you could take this a step further and you could create another filter where you could just do .exe or whatever the extension is that you're interested in for the spearphish campaign that went on. So you can actually filter it just looking to see if the user double-clicked on it, or if the user clicked on it and ran it, it's going to show up inside of this content.outlook directory. That's where the malware will be written out for execution. And so you're going to get a timestamp showing when they clicked it, because that's going to be the creation time. You're going to get a timestamp that shows when it finished executing and then eventually deleted, because the attachment will be closed. And you can use that as a starting point for the rest of your analysis. So there's really a lot of fun stuff you can do there. We also do something similar for recycle bin stuff, because as many of you should know, is that, again, recycle bins changed as well from Windows XP, where there's no longer a handy-dandy info2 file that we can use to say, hey, look, here's a nice record, and it's carvable if it's deleted. It shows us exactly when something was placed in the recycle bin and wasn't removed from the recycle bin. And instead, they replaced it now with these $R, $I files, where $R is the content of the file and I, or the index, is the index of the name of the file itself. One of the problems we had before is that the file's timestamps don't actually change because it's a move for the $R file. So we don't get to see the exact time that was placed in there. Instead, we have to refer to the $I files, and we have to match it up. It's kind of a bit of a pain. So in this case, what we could actually do is we can actually just look for the $R's being placed inside of here. Because when we see them being placed, we'll get a timestamp. Here it is, USN record time, showing us exactly when these files or folders are actually placed in the recycle bin. And then after that, we can see when they're deleted from the recycle bin. So you can see here we have a couple of different signatures for that, sent to parent folders moved in and deleted files. Again, there's no magic here. Our filters aren't doing anything incredibly complicated. There are some that do, but in this case I'm showing you some pretty basic ones that you can replicate in the free version. Because in this case what we're doing is these are renames showing files being moved from the folder that they were once in to the renamed version in the recycle bin. Other things that are really useful to do that you can create filters for are filters for prefetch. So you can either do it by the Windows directory prefetch, or you can do *.pf inside your filter, and that's going to bring up all the deleted prefetch files. Why is it useful? Well, every time a prefetch is recreated, every time that file is deleted, or every time that it's modified, you can go through and first just say, okay, show me all the changes that occurred to the prefetch files. So you can see that as they've been updated for each time they're executed. And you can also look for deletions to see what was being ran prior. So again, you can see here when we were creating and getting our evidence for the sample case, we used FTK to do it. So all sorts of really fun stuff. I want to make sure I'm running out of time. Finish going through a couple of topics and advanced topics, and then move on to your final questions. I hope this has been useful to you. And again, remember, I'm going to put up these labs and more up on the blog so you can do this yourself. So advanced topics. Carving USN entries. The question we had earlier was, is there a carving signature? Absolutely. X-Waves carves USNs very, very well. We've made a carving signature for Blade by Digital Detective. We're also going to be creating signatures for in-case as well as FTK to be able to go through and recover USN entries. As well as if you're a commercial user of our tool, we have a carver of our own, as well as an image access utility to be able to extract out this data that we're in final testing on now that we should be releasing. Other things to know, tools other than ours can handle USN journals. There is a Perl script from Parl and Carvey that does it. TZWorks has a USN journal parser. There is a tool by a guy creating Blue Angel that's very good. But what all these don't do that we do, which is I kind of advocate for our tool, even though I use all tools, is it doesn't help you with the analytics and the ability to do the filtering and be able to really play back the journals and sequence and kind of see the state of things. And the thing I really want to make sure that you understand is there are USN journals in places other than system drives. And I'm starting to see more and more USN journals showing up on external hard drives. And that is awesome. Why is it awesome? Because when you get a USN journal on an external hard drive, what you get to see is no matter what computer it's plugged into, as long as it's running Windows and USN aware, so XP and forward, it will update the journal for all the changes that are occurring on the disk with timestamps. So if someone says, oh, I took the disk, but I never did anything with it afterwards, you can actually look at the journal and say, well, actually, it looks like you opened up a Word doc. Why does it, you know they opened a Word doc? Because what do Word docs do? They create temp files each time a document is opened to store those changes. Those temp files are actually created at a rename, so you'll see that links it back to the actual file name. You can also look to see what data has been deleted and copied onto it, but not copied, but not copied from it, because USN journals are partition specific. But you will get file timestamps showing exactly when these interactions were occurring. You can say, well, what computer were you using at this time? Which may lead you to the question, well, why is the USN journal showing up on external drives? And the answer is, if the drive's plugged in long enough and it's NTFS, the system indexer will kick on and create that journal. And then every other Windows operating system that sees that journal will respect it and update it for all the changes it makes, no matter what system it's plugged into. It's really, really cool, and I've been using it a lot, and I really like it. So, with all that being said, it is now 12:54. You can get a free copy of Triforce from gettriforce.com. If you want to know more about what I'm doing in my research, you can follow me on Twitter at HESFblog. or you can read my blog where all these slides as well as the lab will be posted. That's Hacking Exposed Computer Forensics Blog at blogspot.com. And of course, you can just email me, dcowen@g-cpartners.com. And with that, with a couple minutes left, I'm going to open up to any other questions that you have. It's supposed to give you 10 minutes, but hopefully I made up for that by answering questions in the middle.
All right, thank you, David. It looks like we do not have any other questions, so with that, I would like to say thank you so much to our featured speaker, David, for his great presentation and for bringing this content to the SANS community. To our audience, we greatly appreciate you listening in today. For a schedule of all upcoming and archived SANS webcasts, visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.